Totally. Okay, so quiz. We're going to talk about quiz, and then I'll let you work on the warm-up. So quiz on Wednesday is 9-1 and 9-2. There's no calculators. The math is relatively basic. I have faith that you can do these things like square roots and all that good stuff. From 9-1, it was circles and parabolas. So the equation for circles is x minus h squared plus y minus k squared equals r squared, where hk is your center. And then r is your radius. So we covered a couple of different types of questions in this section. One was if you were given the equation and you had to complete the square to get the standard form of the equation. One was where you were given the center and a point on the circle or the end points of the diameter, and then you've got to figure out your equation from there, and then obviously know how to graph the circle. So find the center, count right, left, up, down your radius. So in this the other thing in this section is the parabola, right? So a horizontal parabola and a vertical parabola. If the y is squared and there's a positive p, then it points to the right. If the y is squared and there's a negative p, then it points to the left. If the x is squared and there's a positive p, then it points up. And if the x is squared and there's a negative p, then it points down. So then the vertex is always hk, the h is always with the x, the k is always with the y, okay? If it is a horizontal parabola, then you would figure out your focus by taking the p and either adding it or subtracting it from h. So you're adjusting the x coordinate by adding or subtracting. If it's positive, you're going to add it. If it's negative, you're going to subtract it. And then the directrix is the opposite. So the directrix comes behind or in front of the parabola. If it is p distance away from the vertex and I want to find the directrix and it's towards the facing the right, then I'm going to subtract the p off of it. And then if it's the other way around, I would add the p. And directrix is an equation, so it's an x equals or a y equals. So with a vertical one, now you're adding and subtracting it from the k. So I'm adjusting it vertically. If I'm pointing up, then I'm going to add the p to the y coordinate. If I'm pointing down, I'm going to subtract the p from the y coordinate. If I am pointing up, I'm going to subtract the p from the directrix. And then if I'm pointing down, I'm going to add the p to the directrix. So I'll walk through an example of this, but just so you can get an idea. The three kinds of questions in this section were complete the square again, finding the equation, and graph. You're going to have to complete the square more than once. One of them does not have something on the x squared or the y squared term. One of them does. So be prepared to make sure that you can take that off. There's stuff in the warm-up that will cover that. Okay, ellipses. So there's two kinds of ellipses. Okay, the horizontal where your larger number or larger denominators under the x, vertical where the larger numbers under the y. A is the larger of the numbers. The h and the x still go together, the k and the y still go together, so that would be if your center's not at 0, 0. C squared equals a squared minus b squared. A is the distance from the center to the vertices on the major axis. B is the distance from the center to the co-vertice on the minor axis. And C is the distance from the center to the foci on the major axis. The major axis length is 2a, minor axis length is 2b. So we're going to work through these on the types of these problems on the warm-up itself. Questions on overall concepts with this stuff? Okay, so let's look at 9-2. So the first one says, find the center, the vertices, the foci, and eccentricity of the ellipse. So from this equation, the first thing you should be able to identify is what type of ellipse is it? Which is what? Vertical, right? How do I know that? The bigger one's under the y, and that bigger one, which is a squared, is 36, which makes a 6. B squared is the other one. That's 4, making b 2. And also from this equation, you should be able to get your center. Opposite of what follows x, which is 2. Opposite of what follows y, which is negative 5. Everybody with me so far? Okay, then comes, so we have the center, the vertices. If you want to give yourself the visual on this, this would be a vertical that starts at 2, negative 5, I know it's vertical, so I'm going up and down A. So I'd go up 6, down 6. Those would be my vertices. So if I take that -5 and I add 6, my vertices are at 2, 1, and 2, -11. Then you get co-vertices. So if it asks for vertices, it also wants the co-vertices. I literally will give you a line to put each of these, so it's not like you can get tricked. B is now, because this is a vertical, B is on the major axis would be the horizontal, minor. So I'm going to go right and left. 2 this way, 2 this way. So there's my poorly shaped ellipse, but you can get the idea. So if I take my center and I subtract from the X, 2, I get 0, -5, and then add 2, and I get 4, -5. The next thing on that list is the foci, so I need to know C. Remember, C squared equals A squared minus B squared. So C squared would equal 36 minus 4, which is 32, square root of that, which would be 4 root 2. And the foci are on my major axis. So I'm adding them and subtracting it from the y coordinate of my center. So I would take 2, -5, add and subtract 4 root 2. And you can leave it just like that. You could separate it out. It doesn't matter. If you can't simplify it, I don't have a problem with it. If it was something that was able to be simplified, if you got square root, 16, and so you can add and subtract 4, then I want you to take it to the next step and actually add and subtract 4. Okay, and then the last part is the eccentricity. This is just C over A. So 4 root 2 over 6, which is 2 root 2 over 3. And again, that depends on how flat your ellipse is. So root 34 or 32 is close to root 36. That's like saying maybe 5.5, 5.6 over 6, which is pretty close to 1, which is why it's a little flat. Questions on that one? All right, number 2 says find the standard form of the ellipse and then graph it. So now we're flip-flopping it. Now I'm giving you information about it, and you've got to figure out the equation. So I would, again, recommend drawing yourself a little picture. Vertex being 0 plus and minus 8 means I'm going up 8, down 8. Already that tells you what piece of information? I can find the center halfway between it, right, which would be 0, 0. What else do you know from this?
Vertical.
It's vertical, which means which one's getting the A?
Y.
Good. And there's one more piece of information you can get already. Daniel.
You can find B squared because C squared equals A squared minus B squared.
Well, I don't, like just from the vertex itself, you would get C. Yes, you can do that. But just from the vertex itself, there's one more that you could find. What represents the distance from the vertex to the center? What letter is that? A. Yes? So A is 8. Then it gives you foci is 0 plus and minus 4. So I'm going up 4 and down 4. That's going to be the foci, and that gives me C, right? C is the distance from the center to the focus, which would be 4. So for my equation, I only need to know one more piece of information, which is B. C squared equals A squared minus B squared. So 16 equals 64 minus B squared. Negative 48 equals negative B squared. And B equals square root of 48. Or B squared, which is actually all I need. B squared is 48. If it asked me to identify all those parts, obviously I would square root 48. I would simplify that. But to get the equation, I actually leave it squared, so it doesn't matter. So from the initial part, knowing that it's vertical, it tells me I'm going to get, and the order here doesn't matter. I can say x squared over b squared plus y squared over a squared. Or you can say y squared over a squared plus x squared over b squared. As long as the y gets the a and the x gets the b, the order doesn't matter. So based on that, my center is 0, 0. I'm not adding or subtracting anything from the x or the y. I would get x squared over b squared, which is 48, plus y squared over a squared, which is 64, equals 1. Questions on that one? All right, 3 and 4 both are find the standard form of the ellipse. So now you're given different kinds of pieces of information. 3 says foci is plus and minus 5, 0. So I'm going right, 1, 2, 3, 4, 5. Left, 1, 2, 3, 4, 5. What does that tell you? Horizontal, which means the x gets the a. What else do you know?
A is 7.
Not yet. Just on the foci. So yes, that is true. But just on the foci, what do you know? C is 5. And one more piece of information. Center is 0, 0. The major axis length being 2a tells you that a is 7. Now all I need is b. So c squared equals a squared minus b squared. 25 equals 49 minus b squared. Negative b squared equals negative 24. B squared equals 24. This time the x gets the a. There's still no h or k, so x squared over a squared, which is 49, plus y squared over b squared, which is 24, equals 1. Questions on that one? All right, 4 says vertices 0, 2, and 8, 2. So 0, 2, and 8, 2. Those are my vertices. So what do we know already? Good. Center's not at 0, 0 this time, right? Halfway between there would be 4, 2. You can either do the midpoint formula or you can count because it's going to be horizontal or vertical. What else do you know? What kind of ellipse is this? Horizontal. Which means the x gets the a again. And the other piece of information you could find from center to vertex is how long? Good. Then they give you minor axis length of 2. This is 2b. B is 1. You don't even need C this time. It's not asking you to graph it. It's not asking you to find the focus. So if you don't need it, don't waste your time, right? They already gave you everything you needed to know. This time it's x minus 4 squared over my a squared, which would be 16, plus y minus 2 squared over b squared, which would be 1. Questions on that one? So obviously you're not going to get like 4 different questions of that kind. You're going to get some sort, it's like between 2, 3, and 4, something like that. Okay, one of those. depending on what kind of information you're given, but resulting in the equation. All right, then the last one, and this is good because this is good practice for both 9-1 and 9-2 because we have to complete the square. So find the standard form of the equation, then find the center, the vertices, the foci, eccentricity, and graph the ellipse. So this is putting everything together based on the equation. So I'm going to complete this square twice, once for the x and once for the y, because I have an x squared and an x and a y squared and a y. So when I group them, I get 9x squared plus 36x plus 4y squared plus minus 24y equals negative 36. So I bump the constant to the other side. Now these both have something on the squared, so I got to take it out. So this would be 9x squared plus 4x, leave the space. 4y squared minus 6y, leave the space, equals negative 36. And I'll tell you right now that common mistakes are not taking it off the second term. If you take it off the squared term, you have to take it from the second term. Otherwise, everything from there on out is wrong. All right, now I got to fill in those spaces. So I want to fill in this space. I'm going to say 4 divided by 2 is 2. 2 squared is 4. I add the 4 here. But before I add it to the 36, I have to multiply it by what's on the front, and that's the second most common mistake made. Make sure you multiply it by what's on the front. Second set of parentheses, I would have 6 divided by 2, that's 3. Square it, that's 9. I'm going to add the 9 here. Again, before I add it to the other side, I have to multiply it times the 4 that's on the front. So now I have 9x plus 2 squared, because you square it the first term, square it the last term, take the sign from the middle, plus 4y minus 3 squared equals negative 36 plus 36 cancels out, plus another 36 equals 36. Now, if this was a circle, you'd have to get rid of the numbers on the front of the parentheses, and they would be the same. That's how it works if it's a circle. Like if they were both 9s, you would divide everything by 9. Because it's an ellipse, you have to make sure that the last number is 1. So I'm going to divide everything by 36. So I get x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. And obviously, if this is like this on the quiz, you have to be so careful, because now if that was wrong, everything after it continues to be wrong, right? You're using a wrong formula to find wrong information. So from here, I'm going to identify my center, which is negative 2, 3, whatever, opposite of what follows x, opposite what follows y. Is this a vertical or horizontal ellipse? Vertical, because the a squared is 9, and that's under the y. So a is 3. The b squared is 4, making b 2. So then I plot my center, negative 2, 3. It's vertical, so I'm going up and down the A. I count up 3, down 3, and I go right and left the B. Right 2, left 2. So my vertices, I take my initial center and I'm adding and subtracting A. So from the 3, I'm going to add 3 and subtract 3, or look at your graph because it's already done for you. Negative 2, 6 and negative 2, 0. Co-vertices, that's now horizontal. So from my center, I'm going left and right, or adding and subtracting B. Again, it's already on my graph. Negative 4, 3, 0, 3. It's asking for the foci, so I have to say c squared equals a squared, which is 9, minus b squared, which is 4. C squared is 5. C would be the square root of 5. And the foci lies on the major axis. So I'm going up and down 5 from my center. So the x stays the same, and the y, I add and subtract the square root of 5. Again, you can leave it like that. If it had actually asked, if it was a square root that you could simplify, then obviously you'd find both. But you can leave it like that. If it asked you to graph it, you would approximate root 5 is just a little bit bigger than 4. Root 4, right? So I'd be going just up a little bit bigger than 2 and down a little bit bigger than 2. And then the last thing here is the eccentricity, which is the square root of 5 over 3. Questions on anything ellipse related? How about parabolas or circles? So I'm going to start with the ones that are parabola based because that appears to be where you're struggling the most, and then I'll kind of go back up to the other ones. Number 2 says, what are the coordinates for the focus? So the first thing you got to look at is what kind of, first of all, it's parabola, obviously, right? Only one of them is squared. If the y is squared and that is a negative 8, that tells you that it's facing in which direction? Y? Well, this makes sense. The y would either be right or left, right? And if it's a negative 8, that means the p is negative. That means it's pointing left, yes? Okay. So then the 8p, negative 8, equals 4p, meaning p is a negative 2, okay? The negative just tells you which direction it's facing. It doesn't really mean you need to like count in a negative way. Don't let that confuse you. Just know that that's facing left, which means I have to move 2 places to the left to get the focus inside the parabola. So if my vertex, which is negative 1, 4, and I get that from opposite of x, opposite of y, right, is moved left 2 places, and I'm taking that negative 1 and I am subtracting 2 from it, which means that it is negative 3, 4. Does that make sense? Yes? Okay. Number 3, what's the equation of the directrix? So again, parabola, otherwise it doesn't have a directrix. This time the x is squared and 4 is positive. So which way is this facing? Okay, good. That was faster. Gives me a little bit better. All right, so the vertex would be negative 3, negative 5. And the directrix is under it if it's opening upward, p away from it. So if 4 equals 4p, then p is 1. So I'm going down 1 point, which means I'm going to shift that negative 5 down 1 more, and I would get y equals negative 6. Questions on that one? Okay. Yeah. I subtracted it because if it's pointing up, then the directrix is below it. It's 1 down from the y. All right, number 1 up here said find the ordered pairs of the vertices of the conic. Obviously, vertices come from knowing that it is negative 1, 4 for my center. This is a vertical, right? So this is up or down. This is horizontal because the 25 is under the x squared. So it's this way and this way. Okay, and I have to go right and left A. A would be 5 because that's 25. So right or left means take your x, add 5 to it, and subtract 5 from it, which is where number, or B is, 4, 4, and negative 6, 4. I'll go back to, let's go to number 6. Okay, what number would go in the blank? So this focus is 2 away from the actual vertex, right? Which means P is 2. This is pointing left, which means it is a negative 2. So I'd get 4 times negative 2, which is negative 8. Should have been C. So you were just finding 4P. You had to know that it was left, making it negative. You had to know that the distance was 2. Number 4 says to find the equation of the figure shown. So the first thing you want to do is identify the center. This is 5, 3. So 5, 3 is your center. Then the major axis is vertical. 1, 2, 3. A is 3. And 1, 2, B is 2. So because it's vertical, I know the A squared is going under the Y, sorry. So x minus 5 squared over 2 squared, which is 4, plus y minus 3 squared over A squared, which is 9, which is D. Number 5 says the foci of an ellipse are located at -2, 3, and 2, 3. This tells me that the center is at 0, 3, which is A. Let's go to 9 first. Okay, given the directrix and the vertex, what would the equation of the parabola be? So if it's a directrix and a vertex, then the vertex would be going this way. If it's pointing to the right, it is a y squared, and it is a positive p. The distance between here is 3, so p is a positive 3. And the vertex is 1, 2. Because it's pointing to the right, you can already rule those two out. Okay, it is 4 times 3, which means it's 12. Y minus 2 squared equals 12 times x minus 1. Equation. So it's y minus k squared equals 4px minus h, right? And then that's your x. This is your h. The p is 3 because the distance from the vertex to the directrix. For number 7, it says which of this is the equation of a circle with a center at 2, 1 that passes through 2, 4. So remember there's 2 ways to do these. One is by taking the hk and the x and y and plugging it into the standard form. So x is 2 minus 2 squared plus y. 4 minus 1 squared equals r squared. This is 0, 3, so 9 equals r squared. And then when I look at the choices, I will need my center to be 2, 1, which means x minus 2 squared plus y minus 1 squared. That eliminates the bottom 2, and then the radius is 9, or the radius is 3, so the equation is 9. 8 says identify the center and the length of A and B. So my center is 0, 0 because you're not adding or subtracting anything from here. That cancels out C and A. And then A squared is 25, which makes A 5. B squared is 4, which makes B 2. That's D. All right, given the equation of the parabola, where would the vertex be? So this is to complete the square situation. I'm going to hope that time was part of the factor this time. So I'd move this over. Okay, you would do 6 divided by 2, that's 3. Square it, that's 9. I'm adding 9 here, and I'm adding 9 here. This becomes y minus 3 squared equals negative 8x plus 24. Standard form can't have anything attached to the x, so you got to take it out. So y minus 3 squared equals negative 8x minus 3. Once you get it to that point, then you can pull out the vertex 3, 3, which is A.